Hello, this is Math Jazz from School, here with another calculus live stream. Without any start, I wanted to do some trigonometry today, so um, pull up some trigonometry problems to do. And of course, if you have your own questions, then please email them to me, and I will get to them as I get to them. So today, what I wanted to do is go through some simple trig questions. Let's start with simple things like converting degrees to radians, okay? So let's say that we have this problem for today. I'm just going to convert, say, 200 degrees. We have to remember that when we do our unit conversion from radians to degrees or vice versa, that pi radians is equal to 180 degrees. So that means that pi radians over 180 degrees equals 1, and when you multiply by 1, you don't change the value of whatever your expression is. So it means that as long as we're going pi 180 multiplied by that factor, we do not change our value. So 200 degrees is equal to 200 degrees times pi over 180. And we notice the degrees and the degrees will cancel, leaving only in radians. So we get, let's cancel some things here. We have 20 goes into 180 9 times, and 20 goes into 210 times, and we have pi. So 10/9 pi radians is equal to 200 degrees. Well, that's not so bad. Let's do one the other direction just for the sake of completion. So convert something from radians to degrees. How about do -5 pi over 2 radians? Well, we want to cancel radians, so instead of using this fraction with the degrees on the bottom and the radians on the top, we're going to multiply by the reciprocal with degrees on the top and radians on the bottom. So let's multiply by have 180 degrees on top and pi on the bottom. So what happens? Well, this pi go away. This 2 cancels with this 180 to give us 90 degrees. The degrees don't cancel, but the radians will. This is equal to, well, 5 times 90 is 450 degrees. It's a negative, and this is our answer now. So 450 degrees. Okay, so that's enough with changing between degrees and radians. So let's move on to something else. How about, let's see. If we're given, say, that the sine of theta is equal to 4/5, what are the remaining trig angles? So we want to find tangent of theta, we want to find cosine of theta, well, letters. We want to find cotangent of theta, secant of theta, and cosecant of theta. Okay, so how would we do this? Well, we know that sine of theta is 4/5, then that means that we have a triangle where our angle is theta, and the opposite over the adjacent equals 4/5. Now I can choose 8 and 10, or 4/5 and 1, or I can choose lots of different lengths that'll give me the right sine value for my triangle. I choose 5/4 because that's pretty much the easiest thing that we could pick. Now we have to figure out, well, what's the remaining side? Well, we know that there is such a thing called a 3, 4, 5 right triangle, so we know the side is 3. Or we could use the Pythagorean theorem to calculate that last side. Either way is fine. But now we know this side is 3 because we remembered our Pythagorean triple, or we used the Pythagorean theorem. And from here, it's pretty simple to go, well, tangent is going to be opposite over the adjacent, so this is 4/3. Cotangent is going to be the reciprocal of that, 3/4. Cosine is going to be the adjacent over the hypotenuse, so that's 3/5. And secant and cosecant are the reciprocals of cosine and sine, respectively. So there are our 6 trig functions. Okay, so let us check to see if there are any emails, and if not, we have more trig problems to do. If you have any questions, send them to mathjazz9@gmail.com. Okay. So, continuing on. We need a new sheet of paper, so we will do this. How about we prove some identities? Okay. So, let's say that we have cosine of pi halves minus x sine x. Can we prove this? Well, there are a few ways that we can. We could go graphically and say that cosine graph looks something like this. Sine graph looks something like this. And so this here, we took cosine and we reflected it. Sorry, if we so we do know that cosine of pi over 2 minus x is equal to cosine of negative x minus pi over 2. But cosine's an even function, so that's just equal to cosine of x minus pi over 2, which is a shift. Cosine will be shifted pi over 2 toward the right. So we get a graph that looks like, instead of getting this for cosine, we get a new graph that looks like this for cosine, which is the same as sine of x. Now, that probably won't suffice for a proof. Well, it depends on what axioms we take in the beginning to see if that's a proof or not. But that is a way to look at what's going on graphically. So one way that we could prove this is if we're allowed to use the angle sum identity. We get cosine of pi over 2 minus x equals, well, cosine of pi over 2 times cosine of x plus sine of pi over 2 times sine of x. It's like we just barely had room on the paper. Now, well, we know that cosine of pi over 2 is 0. And sine of pi over 2 is 1. So 0 times cosine x plus 1 times sine x is sine x. And that might suffice as a proof in most classes. Okay. So let us do another one of these identities. So that was our problem number 4 for the day. Okay. Problem number 5. Let's do another identity. How about do sine x plus cosine x squared equals 1 plus sine of 2x. This one looks a little complicated. Let's see if we can get it to work. Okay, so I'm going to work with this side here, the double angle formula. So we know that 1 plus sine of 2x is equal to 1 plus 2 sine x cosine x from our double angle formula. So that seems like we're on a good start, because the next thing that we're going to do is we're going to say, well, so I'm going to write this up here, that this is the double angle for sine. Or identity, double angle identity. Now, going from this line to this line, we're going to use the Pythagorean identity. And that says that sine squared plus cosine squared is 1. So I'm going to replace this 1 with sine squared x plus cosine squared x. And then we have our 2 sine x cosine x. Okay. Now continuing, I'm going to take this cosine to the back side of my terms. So I have sine 2 squared x plus 2 sine x cosine x plus cosine squared x, and I realize that this is a perfect square. It factors as sine x plus cosine x times itself. That's not times cosine x, that is plus cosine x. Say, oh, well, that was what we were asked to prove in the first place, that sine x plus cosine x squared is equal to 1 plus sine of 2x. And we did just that. Sine x plus cosine x squared equals what? 1 plus sine of 2x. Okay. So that one might have been kind of tricky. But we were still able to do it. Okay, so let's do another identity problem. These are usually considered tricky, so might as well do a few of them. Okay, how about this one? How about do problem number 6 for the day? 1 over 1 minus sine theta plus 1 over 1 plus sine theta equals 2 secant squared theta. We want to prove this, so we have to pick one side and do manipulations that do not change the value of the expression, and keep doing them until we make it look like the other side. I'm going to start with this side. The general rule of thumb for these is look at the more, which side looks more complicated to you. Whichever side that is, do that and try and simplify. It's almost always easier to start with what looks like the complicated side of the equation and simplify until it looks like the other, than to start with the simple side and try and build up complexity to look like the other one. So I'm going to start here. And the first thing I'm going to do is I'm going to try and combine these fractions. So if I multiply this fraction by 1 plus sine theta over 1 plus sine theta. That doesn't change anything. Multiplying by 1 doesn't change the value of a fraction. If I multiply here by 1 minus sine theta over 1 minus sine theta, it won't change the value of this fraction, and then I'll have common denominators so I can combine these fractions. So doing that, I get 1 plus sine theta plus 1 minus sine theta over 1 minus sine theta times 1 plus sine theta. So this is my new fraction. It's equal to the left-hand side of this supposed equation here. So I'm going to write that. Left-hand side equals this. Well, now I can combine terms. I can combine this 2. I have this sine theta minus sine theta, so I get just a 2 on the top. And I can multiply this in the bottom. I get 1 minus sine theta plus sine theta minus sine squared theta. The plus sine theta and the minus sine theta cancel, so I'm left with 1 minus sine squared theta in the denominator. But then, the Pythagorean identity, which I'll write out for you here, that's the identity that says that sine squared theta plus cosine squared theta is 1. That means that 1 minus sine squared theta is equal to cosine squared theta. So that means that this fraction up here can be rewritten as 2 over cosine squared theta. And that can be rewritten as 2 secant squared theta, because cosine, 1 over cosine is just secant. So 1 over cosine squared is secant squared. And that proves exactly what we were asked to. We were asked to prove that this left-hand side of the equation equals the right-hand side. We showed that the left-hand side equals this, equals this, equals this, equals the right-hand side. Okay. So, let us pull another question. Okay. So, for this for this problem, we're going to say that both x and y are in the first quadrant. That means that they are both positive. Okay. Because of that, all of our trig functions will also be positive. Okay, so we say we want to figure out if sine x equals 1/3 and secant y equals 5/4, then what does this expression equal? We have sine of x plus y. Well, we actually have quite a bit of information here. So these two trig functions, being these values, together with the information that x and y are in quadrant 1, they set specific values for all 6 trig functions of each x and y. Okay, so we get to know what from those things we can figure out what the cosine of x is, what the tangent of y is, and all of those. Okay, what we want here is sine of x plus y, which by our angle sum identity, we know is going to be sine x cosine y plus sine y cosine x. Well, we already know what sine x is, and We know secant y is 5/4, so that means cosine of y is 4/5. So we can plug that in here. So this is equal to 1/3 times 4/5 plus sine y cosine x. We still don't know what sine y and cosine x are right now, but we can figure that out. Okay, so how do we figure that out? Well, we draw a triangle. One triangle for x and one triangle for y. We know that sine of x is 1/3, so that means that we need the opposite divided by the hypotenuse to equal 1/3. And secant of y is 5/4, so we need the hypotenuse divided by the adjacent to be 5/4. Because of these, we know that this side here of the y triangle has to be 3 because this is a 3, 4, 5 Pythagorean triple. This one here, we have 1 squared plus blank squared equals 3 squared. 3 squared is 9, so that means that 1, because 1 is 1 squared, plus b squared equals 9. So that means b squared equals 8, which means that b, or the length of this side, is equal to 2 radical 2. Okay, now that we know that, we first need to move to a new sheet of paper. So, on our new sheet of paper, we know that we are looking for sine of x plus y, and we know that that equals, we figured out it equals 4/15 plus sine y cosine x. And we know that sine of y, well, looking at this, sine of y is going to be the opposite over the adjacent, so that's 3/5. 4/15 plus 3/5 times cosine of x. Cosine is the adjacent over the hypotenuse, so that's going to be 2 radical 2/3. So we get, looks like 4 plus 6√2 over 15. Okay. So let us move to our last question for the live stream. And let's see. Pick one for a different type. One more trig function of a different type. How about, okay. How about, and this will be problem 7 for the day, I think. Problem 8. Problem 8 is going to be, we want to figure out the sine of the arctangent of x. So, we want to simplify this to get rid of all trig functions and arctrig functions. The first thing to do is we want to draw a triangle. And we know that the arctangent of x is supposed to be, well, arctangent takes in a ratio of sides and spits out an angle. So this is the angle it's going to spit out. But we need to know what ratio between the sides is equal to x. Well, arctangent is related to tangent. Tangent is the opposite over the adjacent. So we could have picked anything we wanted to be this side, so long as when I divide this side by this side, I get x. Because x is the argument of the arctangent. So I picked x and 1 because x divided by 1 equals x. And that was pretty easy. Now I need to know what the sine of this angle is. Because arctangent took in x over 1 and spat out theta. And then sine is taking theta and spitting out the ratio between the opposite side and the hypotenuse. So I need to figure out what the hypotenuse is. Well, hypotenuse is going to be the square root of the square of this side, which is 1, plus the square of that side, which is x squared. So that's the hypotenuse. So our expression simplifies to the opposite over square root of 1 plus x squared. And this is our final problem for today's live stream. So, hope you have a great time learning calculus, and I hope that you feel more confident on your trigonometry. If you have more questions on trigonometry, please email me, and I will make videos on your questions. So, have a great day. Bye.